It's a pleasure to have you here. You've settled into Science Blanket, your sanctuary for quiet discovery. Does the soft, yellow glint of a precious metal ever make you feel like you're glimpsing a fragment of a forgotten world? This evening, we are draping ourselves in the science of the celestial, specifically the heavy, shimmering mystery of gold. While we see it as a symbol of wealth, it is truly a survivor of the stars, countless atoms born in a cosmic fire and scattered across our planet in a silent, ancient rain. From the paper-thin sheets that flutter like golden wings to the deep, heavy seams locked within the dark stone, gold is the physical heartbeat of a universe that never truly disappears. Before we dive in, picture yourself resting in a vault of soft, amber warmth, as safe and unchanging as the element itself. There is no need to dwell on the complexities of atomic weights or the heat of the Earth's mantle tonight. Simply allow the steady, golden weight of time to pull you towards sleep. If this blanket of stardust helps you find your peace, I invite you to subscribe and join our circle of sleepy explorers. Take a moment now for a long, quiet breath. Feel the air fill you and then leave you, as effortless as a falling leaf. Let the tension of the day dissolve into the warm, metallic glow of the room. Release your jaw, let your shoulders go heavy, and settle deep into the comfort of your bed. Let's explore the quiet wonders of gold together. Gold is one of those elements that carries with it an almost mystical quality, and when you really start to explore where it comes from, that sense of wonder only deepens. The gold that we treasure today, the gold that has been crafted into jewelry and coins and artifacts throughout human history, didn't actually originate here on our planet. Most of the gold on Earth came from somewhere far beyond our world, arriving billions of years ago in a cosmic delivery system that sounds almost too fantastical to believe. When our planet was still young and molten, heavy elements like gold sank toward the core, but after the Earth's crust had already formed, meteorites continued to bombard the surface, and these ancient space rocks carried with them precious metals including gold. These celestial visitors, remnants from the formation of our solar system, scattered gold across the face of our world in quantities that would eventually fuel entire civilizations and shape the course of human history. The universe, it seems, has no shortage of gold waiting to be discovered. Out there in the asteroid belt between Mars and Jupiter, there exists a massive metallic asteroid known as Psyche, and scientists believe this single celestial body may contain gold and other precious metals worth not millions or billions, but trillions of dollars. It's almost impossible to comprehend that kind of wealth floating through space, a mountain of metal drifting in the cosmic void, untouched and unreachable by current technology but tantalizing in its promise. The very existence of Psyche reminds us that gold is not rare in the universe, only rare in accessible forms here on Earth. Speaking of Earth, gold has proven to be remarkably widespread across our planet. Every continent, from the frozen expanses of Antarctica to the tropical forests of South America, from the deserts of Africa to the mountain ranges of Asia, has yielded gold to those who sought it. There's something almost poetic about how this element managed to distribute itself so thoroughly, as if the ancient meteorite impact scattered it like seeds across the globe, ensuring that nearly every culture in human history would have some opportunity to encounter this mesmerizing metal. Whether in the highlands of Papua New Guinea or the riverbeds of North America, gold has left its signature across the world. Yet despite this global presence, gold remains genuinely rare when we consider the actual numbers. In the hierarchy of elements found in Earth's crust, gold ranks only 75th in terms of abundance. It's far less common than elements we barely think about, overshadowed by silicon and aluminum and iron in sheer quantity. This relative scarcity is precisely what makes gold so valuable, of course. If gold were as common as copper, it would never have become the standard for wealth and beauty that it represents today. The rarity is encoded in every speck of gold, every grain recovered from the earth. And recovering gold from the earth is no simple matter. The concentration of gold in most deposits is remarkably low, almost frustratingly so. Imagine processing 1,000 tons of solid rock, crushing it, grinding it, treating it with various chemicals, all to extract just 5 grams of gold. 5 grams. That's barely more than a teaspoon of the precious metal for literally 1,000 tons of stone. The economics of gold mining depend on this harsh reality, and it's one of the reasons why only certain deposits are worth mining at all. The gold has to be concentrated enough, or the price has to be high enough, to justify the enormous effort required to separate these tiny amounts of gold from the vastly larger amounts of worthless rock that surround it. Now, if the land seems stingy with its gold, the oceans present an even more tantalizing and frustrating picture. Scientists estimate that the world's oceans contain approximately 20 million tons of gold dissolved in their waters. 20 million tons. It's an almost incomprehensible amount, vastly more than all the gold that has ever been mined from the earth throughout human history. But here's the catch. This gold is so incredibly diluted, spread so thinly throughout the vast volume of seawater, that no economically viable method exists to extract it. The gold is there, suspended in solution, moving with the currents, touching every shore, but it remains tantalizingly out of reach. Various inventors and entrepreneurs over the years have proposed schemes to harvest the ocean's gold, but the energy required to process enough seawater to make it worthwhile always exceeds the value of the gold recovered. And so the oceans keep their treasure, holding it in a form we can measure but cannot claim. Gold appears in some unexpected places, though, including in the natural world in ways that continue to surprise researchers. In the Australian outback, eucalyptus trees have been found with tiny particles of gold in their leaves. These trees send their roots deep into the earth, sometimes reaching down to gold deposits far below the surface, and through the normal process of drawing up water and nutrients, they also pull up microscopic particles of gold. The gold travels through the tree's vascular system and eventually accumulates in the leaves. It's such a small amount that you'd never get rich trying to extract it, but the discovery has actually proven useful for mineral exploration. Prospectors can now analyze the leaves of eucalyptus trees to find clues about gold deposits hidden underground, using the trees as natural sampling tools that have already done the deep drilling for them. For thousands of years before modern industrial mining, most gold was found and collected through much simpler methods. Alluvial gold, which is gold that has been weathered out of rocks and carried downstream by rivers, accumulates in riverbeds where the current slows and the heavy gold particles settle. This is the gold that prospectors would pan for, swirling water and sediment in a shallow pan, letting the lighter materials wash away while the heavier gold sank to the bottom. Rivers are excellent at sorting materials by density, and gold, being so much denser than ordinary sand and gravel, tends to collect in certain predictable locations where the water flow creates natural traps. This alluvial gold, already separated from its parent rock by the patient work of erosion and water, was humanity's first significant source of the metal, fueling gold rushes from California to the Klondike, from Australia to Brazil. But while rivers gave up their gold relatively easily, the truly massive quantities of gold remained locked in solid rock deposits, waiting for industrial-scale mining to make their extraction possible. No place illustrates this better than the Witwatersrand Basin in South Africa, a geological formation that has proven to be the single richest gold deposit ever discovered. Nearly half of all the gold ever mined in human history has come from this one region. The Witwatersrand Basin contains ancient sedimentary rocks laid down billions of years ago, and through processes that geologists still work to fully understand, gold became concentrated in these rocks in amounts that made large-scale mining extraordinarily profitable. The discovery of gold in the Witwatersrand in the late 19th century transformed South Africa, built cities, attracted miners from around the world, and established an industry that continues to this day. The pursuit of the Witwatersrand's gold has driven miners to extraordinary depths. The Mponeng mine, also located in South Africa, currently holds the record as the deepest gold mine in the world, with operations extending approximately 4 kilometers beneath the surface. 4 kilometers straight down into the earth. At these depths, the conditions become almost otherworldly. The rock itself is hot from the geothermal gradient, temperatures that would be unbearable without extensive cooling systems. The pressure is immense. The ventilation systems must work constantly to provide breathable air, and every aspect of the operation requires careful engineering to keep miners safe. The journey to the rock face can take over an hour in the mine elevators. Yet still the mining continues, driven by the presence of gold deposits that remain profitable even at these extreme depths, testament to both the value of gold and the lengths to which humanity will go to claim it from the earth. When you try to imagine all the gold that humanity has ever pulled from the earth, it helps to have some concrete numbers to anchor that image. Throughout all of recorded history, from the ancient Egyptians to modern industrial operations, approximately 187,200 tons of gold have been mined. That's the cumulative result of thousands of years of human effort, of countless miners in countless locations, of primitive panning operations and sophisticated chemical extraction processes, all added together into one staggering total. And yet, despite that impressive number, gold remains remarkably rare compared to other metals. We've extracted millions upon millions of tons of iron and copper and aluminum, but gold, even after all this time and all this effort, amounts to less than 200,000 tons. There's a visualization that people often use to help grasp just how much, or perhaps more accurately how little, gold that really represents. If you were to gather every single ounce of gold ever mined throughout human history and melt it all down into pure form, the entire amount would fit into just 3 Olympic-sized swimming pools. 3 pools. All the gold that has funded empires, backed currencies, adorned royalty, filled bank vaults, sparked gold rushes, and inspired countless tales of fortune and adventure, all of it together would occupy such a relatively modest space. It's a testament to gold's density, of course, but it's also a reminder of just how rare this metal truly is. We think of gold as this ubiquitous symbol of wealth, but in physical terms, there's actually remarkably little of it in the world. What makes this even more striking is that the vast majority of this gold has been extracted quite recently in geological and even historical terms. Over 90% of all the gold ever mined has been pulled from the earth since the California gold rush began in 1849. Before that pivotal moment, thousands of years of human civilization had extracted only a fraction of what we've removed in the past century and 3/4. The technologies of industrial mining, the development of chemical extraction methods, the application of machinery and explosives and systematic geological surveying, all of these advances have allowed us to reach gold that previous generations could never have accessed and to process, or that would have been impossibly difficult to work with using earlier methods. The California gold rush itself was one of those transformative events that changed not just mining but entire societies. When James Marshall discovered gold at Sutter's Mill in January of 1848, he set in motion a migration that would bring 300,000 people to California and fundamentally reshape the American West. The gold rush of 1849, the year that gave the San Francisco football team its name, ultimately produced over 370,000 kilograms of gold. That's a staggering amount to come from what had been a relatively unpopulated and undeveloped region. The environmental impact was severe, with rivers choked with sediment from hydraulic mining and entire hillsides washed away in the search for gold. But the economic and social impacts were even more profound, accelerating California's path to statehood and establishing patterns of boom-and-bust resource extraction that would characterize much of the American frontier experience. Today, the geography of gold production looks quite different than it did during the California Gold Rush or even in the 20th century when South Africa dominated world production. Since 2007, China has led the world in gold production, extracting more of the precious metal than any other nation. This shift reflects both the discovery and development of new deposits within China and the country's massive investment in mining infrastructure and technology. Chinese gold production now accounts for a significant fraction of the world's annual output, a position that gives China considerable influence in global gold markets and represents yet another chapter in the long history of how gold deposits shape economic and political power. While most gold is found in tiny particles requiring industrial processing to extract, occasionally nature delivers something more dramatic. The largest gold nugget ever discovered, found in Australia in 1869, weighed 2,316 troy ounces. The Welcome Stranger, as it was called, was found just barely beneath the surface by two prospectors who literally stumbled across it. Its weight translates to over 72 kilograms of gold in a single piece. The nugget was so large that it couldn't fit on the scales available at the local bank and had to be broken up before it could be properly weighed and assessed. Sadly, like so many of the largest nuggets ever found, the Welcome Stranger was melted down rather than preserved, its value as raw gold taking precedence over its value as a unique natural specimen. Today, such a find would likely be preserved in a museum, recognized as irreplaceable, but in the rough-and-tumble world of 19th-century gold mining, sentiment rarely triumphed over immediate profit. Modern gold refining can produce bars of remarkable size and purity. The largest gold bar ever cast weighed 250 kilograms, roughly 550 pounds. This massive ingot represents an extraordinary concentration of value in a single object, worth millions of dollars at current gold prices. Such bars are typically cast as demonstrations of refining capability rather than for practical commerce. Standard gold bars used in international trade and held in central bank reserves are much smaller, usually around 12.5 kilograms, a weight that represents a balance between value concentration and practical handling. But that 250 kilogram bar stands as a testament to what's possible when a refinery wants to showcase both its technical skill and the sheer impressive mass that gold can achieve. Part of what makes gold so impressive in large quantities is its extraordinary density. A cubic foot of gold, a block measuring 12 inches on each side, weighs approximately half a ton. Imagine trying to lift a footstool made of solid gold. You'd find it completely immovable. This density is one of gold's defining physical characteristics and one reason why it settles so effectively in riverbeds and can be separated from lighter materials through panning. The same property that makes gold sink to the bottom of a prospector's pan makes it dramatically heavy in any substantial quantity. If we shift to metric measurements, the density becomes even clearer. 1 liter of gold, an amount that would fit in a standard milk carton, weighs 19.3 kilograms. That's over 42 pounds in a space the size of a large water bottle. Gold is denser than lead, denser than most metals we commonly encounter. Only a few elements like platinum, iridium, and osmium exceed gold in density. This extraordinary mass relative to volume is part of what makes gold feel so luxurious, so substantial when you hold it. A gold coin has a heft that immediately distinguishes it from coins made of lesser metals. Even a small gold item has a satisfying weight that silver or copper simply cannot match. The rarity of gold, particularly in larger pieces, can be surprising when compared to other rare items. A troy-ounce gold nugget, a single naturally formed piece of gold weighing just over 31 grams, is actually rarer than a 5-carat diamond. We tend to think of diamonds as the ultimate rare gemstone, and they are indeed precious, but the formation of a gold nugget of any substantial size requires very specific geological conditions and a great deal of time. Most gold occurs as microscopic particles distributed through rock. For gold to concentrate into a nugget, it typically must be dissolved and redeposited by hot fluids moving through rock fractures, a process that occurs only in certain geological settings. Large nuggets are rarer still, and truly massive specimens like the Welcome Stranger are almost unimaginably unlikely. So while diamonds capture the popular imagination as symbols of rarity, those who understand geology and mining know that finding a significant gold nugget is, in its own way, an even more remarkable stroke of fortune. If we set aside the history and the economics for a moment and look at gold purely as an element, as a specific arrangement of protons and electrons, we find that gold occupies a particular place in the periodic table with the atomic number 79. That number tells us that every gold atom contains exactly 79 protons in its nucleus, and it's this specific nuclear configuration that gives gold its unique properties. Change that number by even one proton and you'd have a completely different element with completely different characteristics. Atomic number 78 is platinum, 80 is mercury. But 79 is gold. And that precise arrangement of subatomic particles is what makes gold behave the way it does, what gives it the color and malleability and chemical stability that have made it so valuable throughout human history. The atomic mass of gold, which reflects the total number of protons and neutrons in the most common isotope, comes in at 196.96655 atomic mass units. It's one of the heavier stable elements, which makes sense given gold's incredible density. That weight at the atomic level, multiplied across countless trillions of atoms, is what gives gold bars their impressive heft and gold coins their satisfying weight in the palm of your hand. The nucleus of a gold atom is packed with particles, stable and unchanging across billions of years, and this stability is part of why gold doesn't decay or transform into something else over time. When chemists write about gold, they use the symbol Au, and this abbreviation has a story of its own. It comes from the Latin word aurum, which means shining dawn. The Romans who coined this term were capturing something essential about gold's appearance, that warm glow that does indeed resemble the light of early morning sun. This linguistic connection between gold and dawn light has persisted through 2,000 years of scientific development. Even as we've learned about atomic structure and electron shells, even as chemistry has become a rigorous science far removed from the poetic observations of ancient scholars, we still honor that Roman perception by using their word every time we write the chemical formula for gold. One of gold's most immediately recognizable characteristics is its color, and this turns out to be truly unique among metals. Gold is the only naturally occurring metal that is yellow. Other metals might achieve a yellowish appearance through oxidation or alloying, brass being the most familiar example, but pure elemental gold is yellow straight from the Earth. This color arises from the way gold's electrons interact with light, a consequence of relativistic effects that occur because gold's electrons are moving at speeds that are a significant fraction of the speed of light. These relativistic effects alter the energy levels of gold's electrons in ways that cause the metal to absorb blue light and reflect yellow and red wavelengths. It's a fascinating intersection of quantum mechanics and relativity, both of Einstein's great revolutions in physics, combining to give gold its distinctive warm hue. Like all metals, gold will melt if you heat it sufficiently, though the temperature required is quite specific. Gold melts at 1064 degrees Celsius, or 1947 degrees Fahrenheit. This melting point is low enough that ancient civilizations could achieve it with charcoal fires and bellows, which is one reason why gold working developed so early in human history. The ability to melt gold and pour it into molds, to cast ingots and create complex shapes, was accessible to Bronze Age smiths with relatively simple technology. This melting point is high enough that gold jewelry won't melt in normal wear, surviving even house fires in many cases, but low enough that refiners and jewelers can work with the metal without requiring the extreme temperatures needed for iron or platinum. If you continue heating gold beyond its melting point, eventually it will boil and turn into a gas, though you'd need to reach 2808 degrees Celsius to see this happen. That's 2808 degrees, hot enough to vaporize rock, hot enough that you'd need specialized equipment even in a modern laboratory to achieve and contain such temperatures. Gold vapor would be an unusual sight, atoms of this heavy metal floating free in gaseous form, but at temperatures where gold boils, nearly everything else would have long since vaporized as well. In practical terms, almost no one ever encounters gold in its gaseous state, but the boiling point exists as a fixed physical property, another data point in gold's chemical profile. What has made gold particularly valuable throughout history, beyond its beauty and rarity, is its extraordinary chemical stability. Gold is completely non-reactive under normal conditions. It does not corrode, does not rust, does not tarnish. An iron tool left outdoors will rust into uselessness within years. Silver will tarnish, developing a black coating of silver sulfide. Copper turns green with verdigris. But gold can sit exposed to air and moisture for thousands of years and remain essentially unchanged. Gold artifacts recovered from ancient tombs emerge looking almost as fresh as the day they were buried, their surfaces untouched by the chemical processes that reduce other metals to oxides and corrosion products. This permanence is what allowed gold to serve as a reliable store of value across generations and why gold coins could circulate for centuries without degrading. The chemical inertness of gold extends to resistance against most acids. While many metals will dissolve readily in strong acids, gold remains impervious. Hydrochloric acid, which can dissolve iron and zinc and many other metals, has no effect on gold. Nitric acid, powerful enough to dissolve copper and silver, cannot touch gold either. You can immerse a gold ring in either of these corrosive liquids and remove it completely unchanged. This resistance made gold useful for certain applications requiring chemical stability, but it also created challenges for refiners who needed to purify gold or separate it from other metals. Medieval alchemists discovered that while gold resisted individual acids, it would dissolve in a particular mixture. Aqua regia, which translates to royal water, is a combination of hydrochloric acid and nitric acid mixed in a specific ratio, typically 3 parts hydrochloric to 1 part nitric. This mixture is more powerful than either acid alone because the two acids work synergistically. The nitric acid acts as an oxidizer, and the hydrochloric acid provides chloride ions that form soluble complexes with the gold. Together they can dissolve gold, turning the solid metal into a solution of gold chloride. The name royal water was entirely appropriate, as this was the water that could dissolve the most noble of metals, the king of elements. Today, aqua regia remains important in gold refining and in analytical chemistry whenever gold needs to be dissolved for analysis or purification. When you have gold in its highest purity, refined to remove every trace of other elements, you're left with a metal that has virtually no sensory characteristics beyond the visual. High-purity gold is completely odorless. Unlike copper, which has a distinctive metallic smell, or iron which can impart a scent to your hands, gold has no smell whatsoever. Similarly, gold is tasteless. While we wouldn't recommend tasting random metals for obvious safety reasons, pure gold can actually be used as a food decoration. Those gold leaf flakes sometimes placed on fancy desserts or floated in expensive drinks. The gold passes through the digestive system completely unchanged and unabsorbed, contributing nothing to flavor or nutrition, as inert in the human body as it is in the ground. This complete lack of reactivity, of odor, of taste, makes gold almost ghostly in a way, present and beautiful to look at but otherwise making almost no impression on the chemical world around it. Beyond its chemical stability and distinctive color, gold possesses physical properties that have made it uniquely suited to human craftsmanship for thousands of years. Gold is extraordinarily malleable and ductile, two related but distinct characteristics that describe how the metal responds to mechanical force. Malleability refers to how easily a metal can be hammered or pressed into thin sheets without breaking, while ductility describes how readily it can be drawn out into wires. Gold excels at both to a degree that surpasses almost every other metal. This combination of properties has allowed artisans throughout history to work gold into forms that would be impossible with harder, more brittle materials. The extent of gold's malleability becomes clear when you consider what can be done with even a tiny amount of the metal. Take just 1 gram of gold, about the weight of a small paperclip, and through careful hammering and beating, that single gram can be transformed into a sheet covering 1 entire square meter. 1 gram spread across a surface the size of a small tabletop. The resulting sheet would be so thin as to be almost translucent, fragile and delicate, but continuous and intact. This is possible because gold's atomic structure allows the atoms to slide past one another without the bonds between them breaking. The metal deforms rather than fractures, flowing under pressure like a very slow, very stiff fluid. If we scale up slightly, the numbers become even more impressive. 1 ounce of gold, about 31 grams, can be hammered into a sheet measuring 9 meters on each side. That's a square sheet big enough to cover a medium-sized room, all from a single ounce of metal. The gold leaf used by artisans and gilders is created through exactly this process, though typically not quite to such extremes. Gold beaters historically would place small pieces of gold between sheets of specially prepared animal membrane or special paper and hammer them repeatedly, gradually spreading the gold thinner and thinner. The resulting gold leaf might be only a few hundred atoms thick, so thin that light can pass through it with a greenish tinge, yet still structurally sound enough to be lifted carefully and applied to surfaces for decoration. The ductility of gold is equally remarkable. Gold can be drawn out into wire of extraordinary fineness. A single ounce of gold can be stretched into a continuous thread over 50 miles long. 50 miles from 1 ounce. The wire would be microscopically thin, far too fine to see easily with the naked eye, but it would remain intact and conductive along its entire length. This property has made gold useful in electronics where extremely fine wires are needed to make connections in integrated circuits and other miniaturized devices. The gold wire won't corrode, won't break down chemically, and maintains its electrical conductivity even when drawn to barely visible dimensions. Gold leaf can be manufactured to such thinness that it begins to resemble something more like thread than sheet metal. At extreme thinness, gold leaf takes on an almost textile quality, flexible enough to drape and fold in ways that seem impossible for a metal. Artisans working with the thinnest gold leaf must work in perfectly still air because even a slight breeze can send the fragile sheets floating away. The leaf clings to surfaces through slight electrostatic attraction and must be handled with special brushes rather than fingers. This gossamer-thin gold has been used for centuries in illuminated manuscripts, on religious icons, on architectural details, and anywhere humans wanted to capture gold's glow while using the absolute minimum amount of material. Pure gold, unalloyed with any other metal, is remarkably soft. Unlike metals we typically think of as hard and unyielding, pure gold can actually be molded and shaped by hand. You can press your fingernail into a bar of pure gold and leave a mark. You can bend pure gold wire with little effort. This softness is precisely why most gold jewelry isn't made from pure gold but rather from alloys that mix gold with harder metals like copper or silver. The carat system reflects this, with 24-carat gold being pure and lower carat numbers indicating increasing amounts of other metals added to provide hardness and durability. An 18-carat gold ring contains 75% gold and 25% other metals, enough to make it resistant to the dents and scratches that would quickly mar a ring of pure gold. But that pure gold, soft as modeling clay, remains important for certain applications where its complete chemical inertness matters more than mechanical strength. Gold's excellence isn't limited to its mechanical properties. The metal also conducts heat and electricity exceptionally well, ranking among the very best conductors available. Only silver and copper conduct electricity better than gold, and both of those metals have the disadvantage of oxidizing over time. Gold's combination of excellent conductivity and complete resistance to corrosion makes it invaluable in electronics. The contacts in high-reliability electronic systems, from spacecraft to medical devices, are often plated with gold precisely because those connections will never corrode and will maintain perfect conductivity indefinitely. Every smartphone contains a small amount of gold in its circuitry, and the gold is there not for prestige but for its superior electrical properties. For people who wear jewelry, one of gold's most appreciated characteristics is that it's hypoallergenic. Gold does not provoke allergic reactions in the vast majority of people, making it safe for even the most sensitive skin. While nickel and certain other metals commonly used in cheaper jewelry can cause contact dermatitis in susceptible individuals, gold jewelry can typically be worn by anyone without concern. This biocompatibility extends beyond mere lack of allergic reaction. Gold is genuinely inert in contact with human tissue, which is why gold has found medical applications. Gold alloys are used in dentistry for fillings and crowns because they won't react with saliva or food acids. Tiny gold particles are being explored for drug delivery and cancer treatment. The same chemical stability that prevents gold from tarnishing also prevents it from interacting harmfully with living tissue. When we zoom down to the atomic scale, gold atoms themselves are remarkably small, as all atoms are. A single gold atom measures approximately 0.144 nanometers in diameter. A nanometer is 1/1000th of a meter, so we're talking about dimensions far too small to see even with conventional microscopes. Atoms of different elements vary in size, and gold, being a heavy element far down the periodic table, is actually somewhat larger than lighter atoms like carbon or oxygen. But large or small in atomic terms, the scale remains incomprehensibly tiny. Billions upon billions of gold atoms fit in a space smaller than the head of a pin, and it's only in these vast numbers, these astronomical collections of individual atoms, that gold's properties manifest in ways we can perceive and use. Strangely, unexpectedly, gold exists not just in jewelry boxes and bank vaults but in much more intimate proximity. The human body contains trace amounts of gold. The quantity is truly minuscule, perhaps 0.2 milligrams in an average adult, but it's there, distributed through tissues, present in blood. How it gets there remains something of a mystery, likely absorbed in minute quantities from food and water where gold exists at barely detectable concentrations. The gold serves no known biological function. We don't need it, and it doesn't harm us. It simply exists in our bodies as an incidental component, a few atoms of this ancient, stable element that arrived on Earth in meteorites billions of years ago, that has passed through the environment and somehow ended up incorporated, however briefly, into living tissue. It's a poetic thought in a way, that we each carry within us a fragment of the same substance that has fascinated humanity for millennia, though in quantities far too small to ever extract or appreciate except as an interesting fact, a small wonder to contemplate as you drift toward sleep. The story of gold and humanity extends back through the mists of prehistory to a time when our ancestors were just beginning to work with metals at all. Gold and copper were the first metals that humans discovered and began to use, with evidence of both dating back to around 5,000 years before the Common Era. These weren't accidental discoveries in the sense of stumbling upon refined metal, but rather the recognition that certain unusual stones and nuggets found in riverbeds were different from ordinary rock, that they could be shaped and worked in ways that stone could not. Gold, because it occurs in pure metallic form and doesn't require smelting from ore, was particularly accessible to early metalworkers. They could find it, recognize its unusual properties, and begin crafting it into objects without needing to understand complex metallurgical processes. This early familiarity with gold gave it thousands of years to become embedded in human culture before the Iron Age even began. In ancient Egypt, a civilization deeply concerned with the divine and the eternal, gold took on profound symbolic meaning. The Egyptians believed that gold was the flesh of the gods, the physical substance from which divine bodies were made. This wasn't mere metaphor for them but a genuine theological understanding. The imperishability of gold, its resistance to decay and corruption, aligned perfectly with Egyptian concepts of eternal life and divine permanence. The gods were golden because they were eternal and unchanging, just as gold itself never tarnished or aged. This belief influenced everything from the decoration of temples to the elaborate gold work found in royal tombs. When Tutankhamun was buried with his famous golden mask and countless other gold artifacts, these weren't simply displays of wealth but theological statements, preparations for the pharaoh's transformation into a divine being whose body, like the gods themselves, would be golden and eternal. The Egyptians were also practical miners and refiners who developed sophisticated techniques for extracting gold from river deposits. One method they employed involved using sheepskins to trap fine gold particles from water. They would place fleeces in streams where gold was known to occur, allowing the water to flow through the wool. The gold dust, being heavier than the sediment, would become caught in the fibers of the fleece while lighter materials washed through. After sufficient time, the fleeces would be removed and burned, leaving behind the concentrated gold that had accumulated in the wool. This technique was effective and widely used throughout the ancient Mediterranean world. Interestingly, scholars believe this practice may have inspired the Greek myth of the Golden Fleece, the magical sheepskin sought by Jason and the Argonauts. What was actually a mundane if ingenious mining technique became, through the alchemy of storytelling, a legendary treasure guarded by dragons and kings, the ultimate prize of heroic quest. The ancient Egyptians also left us one of the most remarkable documents in the history of mining. The Turin Papyrus, dating from around 1200 BCE, contains what is recognized as the oldest surviving map of a gold mine. This map shows the layout of mining operations in the Wadi Hammamat region, indicating tunnels, living quarters for workers, and the locations where gold-bearing stone was being extracted. The papyrus demonstrates the sophistication of Egyptian mining operations and their understanding of geological and geographical documentation. That such a map was created and preserved tells us how important gold mining was to the Egyptian state, important enough to warrant careful planning and record-keeping that would aid future operations. Not every ancient civilization immediately saw gold primarily as currency or a medium of exchange. The ancient Jewish people, as recorded in biblical texts and archaeological evidence, certainly possessed gold and valued it for making religious objects and decorative items, but they did not initially develop gold coinage or use gold as a standard currency for everyday transactions. Their economic system relied on other mechanisms, including barter and credit relationships. Gold in ancient Jewish culture was predominantly reserved for the sacred, for objects used in temple worship, where its imperishability and beauty made it appropriate for honoring the divine. The shift to using gold as currency would come later, influenced by contact with Greek and Roman monetary systems. The ancient Greeks, always inclined toward philosophical speculation about the nature of the world, developed their own theories about gold's origin. They believed that gold was formed from sunlight somehow mixing with water, a notion that seems charmingly poetic to modern ears but represented a genuine attempt to understand natural phenomena. The Greeks observed that gold was often found in water, in streams and rivers, and they knew the sun as the most powerful force in their world, the source of light and life. The connection between the radiance of the sun and the glow of gold seemed obvious, and the Greek mind, seeking to understand cause and effect, proposed that one gave rise to the other. While we now understand gold's true origin in stellar nucleosynthesis and planetary formation, the Greek hypothesis captured something true about gold's appearance, its warm solar color that does indeed resemble captured sunlight. Across the Atlantic, in a civilization that had no contact with the ancient Mediterranean world, the Incas developed their own powerful mythology around gold. They called gold the tears of the sun, believing it to be a sacred substance that literally fell from the sky as drops shed by the sun god Inti. For the Incas, gold wasn't primarily valuable for economic reasons but was sacred, connected to the divine, appropriate for religious ceremonies and for adorning temples and rulers who were themselves considered semi-divine. The most important temple in the Inca capital of Cusco, the Coricancha, or Temple of the Sun, was reportedly covered in gold plates, its interior filled with golden statues and decorations. When Spanish conquistadors arrived and saw the Incas' gold, they understood it only as wealth to be plundered, completely missing its religious significance. The resulting clash between European gold as currency and Andean gold as sacred substance was one of the many tragic misunderstandings of the conquest. Moving back to the Mediterranean world, one of history's most famous women understood the power of gold as symbol and statement. Cleopatra, the last pharaoh of Egypt, wore gold not merely as jewelry but as a deliberate display of divine authority and earthly wealth. She was carrying forward ancient Egyptian traditions, presenting herself as a living embodiment of the goddess Isis, and gold was essential to that presentation. When Cleopatra appeared before Julius Caesar, when she later met Mark Antony, she did so adorned in gold that proclaimed her status as both queen and goddess. The Romans, accustomed to wealthy leaders and impressive displays, were still reportedly awed by Cleopatra's use of gold, by the sheer quantity and artistry of the golden objects that surrounded her. In her hands, gold was theater, politics, and theology all intertwined. Gold served not only as symbol and ornament but as a practical facilitator of long-distance trade. The trans-Saharan trade routes that connected sub-Saharan Africa with the Mediterranean world for over 1,000 years operated in significant part as gold trade. West African kingdoms, particularly Ghana and later Mali, controlled rich gold deposits and traded gold northward across the desert. This gold traveled by camel caravan through brutal conditions to reach North African ports, from where it dispersed throughout the Mediterranean and into Europe. The profits from this trade built empires. Mansa Musa, the 14th century ruler of Mali, became legendary for his wealth, supposedly distributing so much gold during his pilgrimage to Mecca that he temporarily disrupted the economy of Egypt by flooding the market with the metal. The trans-Saharan gold trade was so important that it shaped political boundaries, funded kingdoms, and influenced the religious and cultural exchanges between Islamic North Africa and sub-Saharan civilizations. Before gold or any metal became standardized currency, human societies needed other ways to facilitate exchange and measure value. In many pastoral societies across the world, livestock served this function, and cattle in particular became a kind of proto-currency. You could measure wealth in cattle, trade cattle for goods, and use cattle as a store of value that could be maintained and even increased through breeding. The connection between cattle and money persists in language even today. The Latin word for money, pecunia, derives from pecus, meaning cattle. The word capital, fundamental to economics, shares roots with cattle. This wasn't as primitive a system as it might seem. Livestock represented a form of wealth that was mobile, that could reproduce itself, and that had intrinsic value as food and labor. But livestock had obvious limitations. They required care and feeding, they could die or be stolen, and they weren't easily divisible for smaller transactions. Gold and other precious metals solved these problems, offering a store of value that was imperishable, easily divided, and far more portable than herds of animals. The transition from livestock to metal money was one of those pivotal developments that enabled more complex economies and larger-scale trade networks, another step in gold's journey from river-found curiosity to foundation of civilization. The invention of coinage was one of those transformative innovations that changed the nature of commerce and economy forever, and gold played a central role from the very beginning. The first gold coins appeared around 700 to 560 years before the Common Era in the ancient kingdom of Lydia, located in what is now western Turkey. Before coins, gold might be used in trade as dust, as nuggets, or as standardized bars, but these forms had significant drawbacks. How could you be certain of the weight? How could you verify the purity? Every transaction required careful measurement and assessment. The Lydian innovation was to create small, standardized pieces of metal stamped with official marks guaranteeing their weight and value. The king's seal on a coin meant you didn't need to weigh it or test it. You could trust that it contained what it claimed to contain, and this trust made transactions infinitely easier. Commerce could move faster, markets could function more efficiently, and the very concept of money as we understand it began to take shape. These early Lydian coins weren't made of pure gold but rather of electrum, a naturally occurring alloy of gold and silver. Electrum appears in nature where gold and silver deposits occur together, and the resulting metal has a distinctive pale color, lighter than pure gold but not as white as pure silver. The Lydians used what nature provided, and the slight variability in electrum's composition wasn't initially seen as a problem. Over time, however, mints learned to refine metals and create more standardized alloys, and coins of pure gold or controlled gold-silver mixtures became the standard. But those first electrum coins from Lydia remain landmarks in economic history, the ancestors of every coin in every pocket in the modern world. As coinage spread throughout the ancient and medieval world, certain coins gained reputations that transcended their places of origin. Venice's gold ducat, first minted in the late 13th century, became arguably the world's most trusted coin for 500 years. The Venetian Republic maintained strict quality control over its ducat, ensuring consistent weight and purity across centuries of production. Merchants from London to Constantinople to Cairo would accept Venetian ducats without question because they knew exactly what they were getting. The ducat became a kind of international currency long before modern concepts of reserve currencies or global monetary systems. Its success was built entirely on reputation and trustworthiness, on Venice's commitment to never debase its coinage for short-term gain. This restraint required discipline because the temptation to cheat was always present, to reduce the gold content slightly and pocket the difference, but Venice understood that its credibility was worth more than any temporary profit from fraud. Not every ancient state showed such restraint. In ancient Rome, gold prices and currency values fluctuated dramatically over the centuries as different emperors made different decisions about money supply and coin quality. During the early empire, gold currency was relatively stable, but as Rome faced increasing financial pressures from military expenses and administrative costs, emperors began reducing the precious metal content of coins while maintaining their face value. This debasement led to inflation, and gold prices, measured in the debased silver and bronze currency, rose accordingly. By the late empire, the monetary system was in chaos, with different regions and different eras having entirely different standards. The economic historians who study Roman coinage can track the rise and fall of imperial fortunes through the changing gold and silver content of coins, reading in the metal itself a story of ambition, desperation, and eventual collapse. There's a famous story from Roman history that connects geese and gold in an unlikely tale of salvation. In 390 BCE, Gauls invaded Rome and besieged the capital, the fortified hilltop that served as the city's last refuge. The defenders were exhausted and struggling to maintain watch through the night when a group of sacred geese, kept in the temple of Juno, began honking loudly at the approach of Gallic soldiers attempting a stealthy night assault. The noise awakened the Roman guards, who were able to repel the attack and save the gold reserves stored in the capital. Whether this story is literally true or embellished over centuries of retelling is debatable, but it became a cherished piece of Roman lore, a reminder that salvation can come from unexpected quarters. The Romans honored those geese afterward, and the story endured as a testament to divine protection and the importance of staying vigilant when guarding treasure. The Roman connection to gold extends into language itself. The words money and mint, fundamental terms in any discussion of currency, both derive from moneta, a title of the Roman goddess Juno. The Temple of Juno Moneta housed Rome's mint, the facility where coins were produced, and over time the goddess's name became associated with the money itself. When languages evolved from Latin into the Romance languages and influenced English, this connection persisted. Every time we talk about money or a mint, we're invoking, however unknowingly, an ancient Roman goddess whose temple once rang with the sound of hammers striking coin blanks, where gold and silver were transformed into the currency of empire. Moving forward to more recent history, the United States produced solid gold coins for circulation up until 1933. These weren't commemorative pieces or special issues but actual currency intended for use in transactions. Various denominations existed, from small gold dollars to large double eagles worth $20. During this era, the US operated on a gold standard, meaning that paper currency could be exchanged for actual gold coins on demand. The decision to abandon gold coinage and, shortly thereafter, to prohibit private gold ownership came during the depths of the Great Depression. President Franklin Roosevelt, seeking to combat deflation and stabilize the banking system, ordered Americans to turn in their gold coins and gold certificates in exchange for paper money. The government melted down most of these coins, and gold ownership by private citizens remained illegal in the United States until 1974. Those pre-1933 gold coins that survived are now collector's items, valued far beyond their gold content for their historical significance. One particular gold coin from that final year became perhaps the most valuable coin in history. The 1933 Double Eagle, a $20 gold piece, was minted but never officially released for circulation because Roosevelt's gold confiscation order came down before the coins could be distributed. Most were melted down, but a small number somehow escaped destruction. For decades these coins existed in a legal limbo, technically government property that had never been legally issued but nonetheless in private hands. One specimen went through a complex legal journey involving the Secret Service, auction houses, and ultimately a lawsuit that ended with the coin being sold at auction in 2002 for $7.59 million. A single gold coin, worth $20 in face value and perhaps $1,200 for its gold content, brought over $7.5 million because of its story, its rarity, and its connection to a pivotal moment in American economic history. Not all gold is created equal in the eyes of collectors and jewelry buyers. Welsh gold, mined in Wales, has a special reputation for rarity and quality. The pink-hued gold from Welsh mines has been used for British royal wedding rings for generations, creating a tradition and a mystique that extends far beyond the metal's intrinsic properties. But Welsh gold is no longer being actively mined. The deposits are exhausted or uneconomical to work, and the small amount of Welsh gold that enters the market comes from existing stocks and recycled jewelry. This makes Welsh gold increasingly precious not just for its beauty but for its provenance, for the story it carries of a particular place and a particular geological formation that produced something special and is now silent. In the modern financial world, where most money exists as electronic records rather than physical coins or bills, gold occupies an unusual position. It's treated as a commodity, certainly, something to be bought and sold like oil or wheat. But it's also treated as a form of money, a store of value that transcends national currencies. This dual nature is recognized officially in gold's possession of its own ISO currency code, XAU. ISO codes are three-letter designations used in international finance to identify currencies. USD for United States dollars, EUR for euros, JPY for Japanese yen. Gold, despite not being issued by any government, has code XAU, with the X indicating a supranational currency and AU being gold's chemical symbol. When central banks report their reserves, gold is listed alongside currency holdings. When investors diversify portfolios, they might allocate a percentage to XAU just as they would to any national currency. 5,000 years after humans first began working this metal, gold retains its status as money, not because any government decrees it, but because, in some deep sense, humanity has never fully moved beyond seeing gold as the ultimate form of wealth, imperishable and universally valued, a currency that transcends empires and economic systems and speaks to something fundamental about value itself. When Howard Carter opened the tomb of Tutankhamun in 1922, he found a burial that had remained essentially intact for over 3,000 years, and what he discovered inside almost defies imagination. The young pharaoh's coffin, or more precisely the innermost of 3 nested coffins, was made of solid gold. Not gold plating over wood, not gold leaf applied to a cheaper base, but solid metallic gold from top to bottom. This innermost coffin contained approximately 1.5 tons of gold, over 3,000 pounds of the precious metal shaped into the form of the king. The weight alone is staggering, but the craftsmanship is even more remarkable. Ancient Egyptian goldsmiths had created a human-shaped sarcophagus of breathtaking beauty, inlaid with semi-precious stones and colored glass, every surface decorated with hieroglyphs and protective deities. The face of the coffin bore the idealized features of the young king, serene and eternal, fashioned from enough gold to represent a fortune even in modern terms, but priceless in its historical and artistic value. That this object survived intact through millennia of tomb robbery and upheaval seems almost miraculous, a testament to the tomb's hidden location and sheer good fortune. Gold appears throughout religious texts and traditions, and nowhere is this more evident than in the Bible, where gold is mentioned over 400 times. From Genesis, where the Garden of Eden is described as having rivers flowing through lands where good gold can be found, through the construction of the tabernacle and temple with their gold furnishings, through the gifts of the Magi bringing gold to the infant Jesus, and on to the New Testament's visions of heaven with streets of gold, the metal weaves through Scripture as a symbol of divinity, purity, and eternal value. The frequency of these mentions reflects gold's importance in the ancient Near East where these texts were written, but it also reflects gold's symbolic power. When biblical authors wanted to convey ultimate value or divine splendor, they reached for gold as the natural metaphor. The metal's physical properties, its beauty and imperishability, made it the perfect material symbol for spiritual truths. Religious architecture has long employed gold to create spaces that inspire awe and contemplation, and few buildings demonstrate this more dramatically than St. Peter's Basilica in Vatican City. The interior of this massive church, one of the most important structures in Christianity, has been adorned with gold leaf applied to countless surfaces. The technique of gilding with gold leaf allows a relatively modest amount of gold to cover enormous areas. The thin sheets of gold are carefully applied to prepared surfaces, adhering through special adhesives, and the result is a gleaming golden surface that catches light and creates an atmosphere of transcendent beauty. The amount of labor required to gild a building the size of St. Peter's was enormous, requiring skilled craftsmen working for years, but the result has endured for centuries. The gold as bright now as when first applied, unaffected by time and the breath of millions of visitors who have passed through those golden halls. In the modern world, gold continues to mark the highest achievements. Nobel Prize medals, given annually to honor the most significant contributions in physics, chemistry, medicine, literature, and peace, contain gold worth several $1,000s each. The medals aren't solid gold, which would make them prohibitively expensive, but they are substantial objects plated with gold to a depth that gives them heft and permanence. The design varies by category, but all Nobel medals share a certain gravitas appropriate to their significance. For recipients, the medal's value isn't in the gold content but in what it represents, the recognition of peers, the place in history, but the presence of gold nonetheless matters. The metal connects these modern honors to thousands of years of human tradition of using gold to recognize and reward excellence. When people think about where gold is stored in large quantities, one location dominates the popular imagination. Fort Knox, officially the United States Bullion Depository, stores roughly 4,600 tons of gold belonging to the United States government. That's about half of the U.S. official gold reserves. Fort Knox became famous partly because of its security, a fortress within a military base, protected by multiple barriers and armed guards, its vault door weighing more than 20 tons. The facility was built during the 1930s specifically to store gold, and for decades it was the most secure storage location for precious metal in the world. No visitors are allowed, no tours given, and this secrecy has spawned numerous conspiracy theories about whether the gold is really there. But periodic audits and official statements confirm that the gold remains, sitting in underground vaults, row upon row of gold bars, a physical manifestation of national wealth and financial stability. The Federal Reserve, America's central bank, holds even more gold than Fort Knox, though most of it belongs not to the United States but to foreign governments and international organizations. The Federal Reserve Bank of New York maintains a vault deep beneath the streets of Manhattan containing over 500,000 gold bars. This gold, stored 80 feet below street level on bedrock, serves as a reserve asset for dozens of countries that prefer to keep their gold in New York rather than shipping it home. When countries settle debts with each other, workers in the vault literally move gold bars from one compartment to another, transferring ownership without the gold ever leaving the building. It's an elegant system that allows international gold transactions to occur with perfect security, the gold itself remaining stationary while only the accounting changes. Across the Atlantic, the Bank of England operates a similar facility that holds more than 5,000 tons of gold in its vault, making it one of the largest gold storage facilities in the world. Much of this gold also belongs to foreign governments and institutions that use London as a trading hub. The Bank of England's vault, located beneath the building in the heart of London's financial district, has been storing gold for over 3 centuries. During World War II, much of the bank's gold was secretly evacuated to Canada for safekeeping, only to be returned after the war ended. Today the vault continues its quiet work, holding assets that represent the financial reserves of nations, rarely moved but always accounted for with meticulous precision. The gold stored in these facilities doesn't come in just any shape or size. International gold trading operates on standards, and the primary standard is the London Good Delivery Bar. This bar, which has become the global benchmark for wholesale gold trading, weighs approximately 400 troy ounces, though the specifications allow for slight variation between 350 and 430 troy ounces. The bar is roughly the size of a smartphone but much thicker and vastly heavier, weighing around 12.5 kilograms or about 27.5 pounds. Each bar is stamped with its precise weight, its purity, which must be at least 99.5% gold, the refiner's mark, and a unique serial number. Only bars meeting these specifications and produced by approved refiners can be traded on the London bullion market without question. These standardized bars allow for efficient international trading, every bar meeting the same criteria and thus interchangeable with any other good delivery bar. Gold purity is measured in carats, a system that divides gold into 24 parts, with 24 carat representing pure gold. 22 carat gold, which contains 22 parts gold and 2 parts other metals, has become standard for many British coins and for much gold jewellery worldwide. The addition of other metals, typically copper or silver, makes the gold harder and more durable while still maintaining most of gold's colour and lustre. 22 carat gold strikes a balance between purity and practicality, soft enough to work but hard enough to resist wear-in objects that will be handled regularly. British sovereigns, those famous gold coins that have circulated since 1817, are made from 22 carat gold, a tradition that continues with modern sovereigns struck by the Royal Mint. Different cultures have developed different units for measuring gold, and in South Asia, the tolar remains an important unit of measurement. A tolar equals 3/8 of a troy ounce, approximately 11.7 grams. This measurement predates the adoption of metric or imperial systems in the region and continues in use particularly in gold markets in India, Pakistan, and neighboring countries. When gold jewelry is bought and sold in these markets, prices are often quoted per tolar rather than per gram or per ounce. The persistence of the tolar demonstrates how deeply measurement systems can embed themselves in commercial practice, surviving changes in government and the introduction of international standards simply because buyers and sellers understand the unit and trust its meaning. Another reminder that gold's story is as much about human culture and tradition as it is about geology and chemistry. The practical applications of gold extend far beyond currency and decoration, and one of the oldest of these uses has been in dentistry. Gold has been used to repair and replace teeth since at least 700 years before the Common Era. Ancient Etruscan dentists were fashioning gold bridges to hold replacement teeth in place over 2,700 years ago, creating dental appliances that would not have looked entirely out of place in a modern dental office. The reasons gold works so well for dental applications are the same reasons it works well for so many other purposes. It doesn't corrode or react with the acids and enzymes present in the mouth, it can be worked into precise shapes, and it's soft enough to be malleable but can be alloyed to provide adequate hardness. Gold dental crowns and fillings were extremely common throughout the 20th century and remain in use today, though modern ceramics and composite materials have largely replaced them for cosmetic reasons. But many people still have gold in their mouths, functional and durable, a use of the precious metal that's completely utilitarian rather than decorative. Gold's chemical inertness means it's safe to ingest, and this property has been exploited in culinary applications, particularly in luxury cuisine. Gold is edible in the sense that it passes through the digestive system without being absorbed or causing harm, and thin gold leaf or tiny gold flakes are sometimes used as decorative elements in high-end dishes and drinks. You might find gold leaf floating on a cocktail at an upscale bar or delicate flakes of gold adorning a chocolate dessert. The gold adds no flavor, contributes no nutrition, and costs far more than any sensible ingredient should, but it does create a visual impact, a literal taste of luxury. The practice dates back centuries. Medieval and Renaissance banquets sometimes featured dishes decorated with gold as a display of wealth and power. Today the tradition continues in a more restrained form, though it still serves essentially the same purpose, demonstrating that gold, the ultimate symbol of wealth, is so abundant in this setting that it can be casually consumed and discarded. Gold has also appeared in medical applications beyond dentistry. For many years, gold was used in the treatment of arthritis, particularly rheumatoid arthritis. Gold salts, compounds containing gold in a form that could be dissolved and injected, were found to reduce inflammation and slow the progression of the disease in some patients. The treatment, known as chrysotherapy from the Greek word for gold, was never fully understood mechanically. Doctors knew it sometimes worked but weren't entirely certain why. The treatment had significant side effects and required regular monitoring, and as newer drugs with better efficacy and safety profiles were developed, gold therapy gradually fell out of favor. But for several decades in the 20th century, many arthritis patients received regular gold injections as part of their treatment regimen, another unexpected medical application for this most ancient of metals. Modern medicine has found new uses for gold at the nanoscale. Gold nanoparticles, incredibly tiny particles of gold measuring just billionths of a meter across, are being used in cutting-edge disease treatments and diagnostic techniques. These nanoparticles have unusual optical properties. They absorb and scatter light in ways that depend on their exact size and shape. Researchers are developing treatments where gold nanoparticles are delivered to tumors and then activated with light or other energy sources, heating up and destroying cancer cells while leaving surrounding healthy tissue unharmed. Gold nanoparticles are also being used in diagnostic tests, where their optical properties make them useful as markers that can indicate the presence of specific diseases or biological molecules. This is gold at its most high-tech, far removed from coins and jewelry, but still exploiting the metal's unique properties, its chemical stability and its interaction with light and energy. The electronics industry has an insatiable appetite for gold, not because circuit boards look better with gold decoration, but because gold provides corrosion-free electrical connections that will function reliably for years or decades. Every smartphone, every computer, every sophisticated electronic device contains small amounts of gold in its circuitry. The gold is typically used in connectors and contacts, places where electrical connections must remain perfect despite repeated use and despite exposure to humidity and temperature variations. A gold-plated contact will never corrode, will never develop the resistive oxide layers that plague copper or other metals, and this reliability is worth the added cost in devices where failure is not acceptable. The amount of gold in any individual device is small, just a fraction of a gram, but multiplied across billions of devices worldwide, electronics represent a significant portion of annual gold consumption. When NASA sent astronauts to the moon during the Apollo missions, they protected those astronauts' eyes with visors coated in gold. The thin layer of gold, almost transparent but with a distinctive golden tint, served a critical purpose. It reflected infrared radiation while allowing visible light to pass through. On the moon, without an atmosphere to filter the sun's radiation, astronauts needed protection from intense heat and harmful wavelengths. Gold, with its unique optical properties, proved ideal for this application. The gold coating kept the visors from overheating while allowing astronauts to see clearly, a perfect balance of protection and visibility. Those iconic images of Apollo astronauts on the lunar surface, their visors reflecting the desolate landscape with a golden glow, are among the most famous photographs in history, and the gold that made those visors functional is part of why those images look the way they do. The use of gold in spacesuits extends beyond visors. Modern spacesuits incorporate layers of gold-coated material throughout their construction to reflect infrared radiation and help regulate temperature. In the vacuum of space, temperature control is a significant challenge. Objects in direct sunlight can become extremely hot, while objects in shadow can become extremely cold. Gold's reflective properties help manage these extremes, bouncing infrared radiation away from the astronaut's body and helping maintain a survivable internal temperature. These gold layers are thin films, nowhere near the thickness of gold foil, but they're essential components in the complex engineering that keeps astronauts alive in one of the most hostile environments imaginable. Back on Earth, gold leaf continues to be used in traditional art, architecture, and the restoration of historic buildings. The technique of gilding, applying gold leaf to surfaces, remains fundamentally unchanged from methods used thousands of years ago. Artisans carefully apply sheets of gold so thin they're almost translucent, using special brushes and adhesives to position the delicate material. Gold leaf is used to restore the gilding on historic monuments, to decorate picture frames and religious icons, to add brilliance to illuminated manuscripts and fine art. The work requires patience and skill, but the results are breathtaking and essentially permanent. Gold leaf applied centuries ago remains bright today, and new gilding, if properly executed, will remain beautiful for centuries to come. The purity of gold is measured using the carat system, with 24 carat representing gold that is essentially pure, typically 99.9% gold or higher. Lower carat numbers indicate gold alloyed with other metals. 18 karat gold is 75% gold and 25% other metals. 14 karat gold, common in American jewelry, is just over 58% gold. 10 karat gold, the minimum that can legally be called gold in the United States, is less than half gold by weight. The carat system provides a standardized way to communicate gold content, though it can be confusing because higher carat numbers mean softer, purer gold, which seems counterintuitive if you're used to thinking that higher numbers should indicate strength. But the system has worked for centuries and remains the standard in most of the world. There's a common misconception about Olympic gold medals that surprises many people when they first learn the truth. Olympic gold medals are not solid gold. They're mostly silver with a thin coating of gold on the outside. The International Olympic Committee requires that gold medals contain at least 6 grams of gold plating over a base of silver, with a total medal weighing at least 550 grams. The last Olympics to award solid gold medals was in 1912, after which the practice was discontinued as too expensive. Modern Olympic gold medals are valuable certainly, worth thousands of dollars for their metal content alone, but they're not the solid gold objects that their appearance might suggest. Still, this doesn't diminish their significance to the athletes who win them. The value of an Olympic gold medal has never been primarily in the metal but in what it represents, the culmination of years of training and sacrifice, the achievement of becoming the best in the world at something. The thin layer of gold that covers the surface is enough to maintain the symbolism, enough to connect these modern awards to thousands of years of tradition in which gold has marked the highest achievements and the greatest honors, a tradition that continues into the present and, no doubt, far into the future. When historians and economists try to identify the wealthiest person who ever lived, one name consistently appears at the top of the list: Mansa Musa, the 14th century ruler of the Mali Empire. His wealth was based primarily on gold, specifically on Mali's control of some of the richest gold deposits in West Africa. The scale of Mansa Musa's wealth is difficult to comprehend in modern terms. When he embarked on his famous pilgrimage to Mecca in 1324, he traveled with a caravan of tens of thousands of people, and he distributed gold so freely along the route that he reportedly caused inflation in the regions through which he passed. In Cairo, his generosity with gold supposedly disrupted the economy for years. Estimates of his wealth, adjusted for modern values, range into the hundreds of billions of dollars, figures so large they become almost meaningless. What's clear is that Mansa Musa possessed gold on a scale that few if any individuals in history have matched, and that this gold gave him power and influence that extended far beyond his kingdom's borders. For all of gold's universal appeal, there exist people who fear it. Orophobia, The fear of gold is a recognized specific phobia, though it's quite rare. Like other specific phobias, agoraphobia can manifest as anxiety, avoidance behavior, or even panic attacks when confronted with gold objects. The origins of such fears are typically psychological rather than based on any actual danger that gold presents, which of course presents none. Someone with agoraphobia might have had a traumatic experience associated with gold or might have developed the fear through other psychological mechanisms. It's a reminder that even the most universally valued substance, something that most of humanity prizes above almost all other materials, can become an object of fear for some individuals, a quirk of human psychology that demonstrates how subjective our responses to the world can be. One of gold's most remarkable properties, and one that becomes increasingly important in an age concerned with sustainability and resource conservation, is that gold is completely recyclable without any loss of quality. You can melt down a gold coin minted 2,000 years ago, refine it, and cast a new bar that is chemically and physically identical to gold that was just extracted from a mine. The recycling process might remove impurities, but the gold itself is unchanged. It doesn't degrade, doesn't weaken, doesn't lose any of its essential properties no matter how many times it's melted and reformed. This means that much of the gold in circulation today is ancient, atoms that have been part of countless objects over the centuries. The gold in a modern wedding ring might once have been part of a Roman coin, or a medieval crown, or a Victorian watch chain. We have no way of knowing the history of individual gold atoms, but we know that they're all still here, still in use, part of a cycle of use and reuse that has continued for millennia. This recyclability is possible because gold does not degrade over time. It doesn't rust like iron, doesn't tarnish significantly like silver, doesn't corrode like copper. Gold pulled from an Egyptian tomb after 3,000 years underground looks essentially the same as it did the day it was buried. Gold coins recovered from shipwreck centuries old emerge from the ocean floor bright and intact. This permanence is what has made gold such an effective store of value throughout history. If you bury gold in your backyard today and dig it up 100 years from now, assuming you or your descendants can remember where you put it, the gold will be exactly as you left it, unchanged by time or exposure to the elements. Few materials share this quality of essential immortality, and it's a significant part of why gold has maintained its value across cultures and centuries. The search for gold and the trade in gold helped shape the early global networks that connected distant civilizations. The gold trade routes across the Sahara linked sub-Saharan Africa with the Mediterranean world and eventually with Europe. The Spanish conquest of the Americas was driven largely by the search for gold, and the massive quantities of New World gold that flowed into Europe fundamentally altered the European economy and helped fund the rise of Spain as a global power. Gold from California and Australia in the 19th century drew immigrants from around the world and accelerated the integration of these regions into global commerce. In each case, the presence of gold created connections between places that might otherwise have remained isolated, building trade networks that eventually carried much more than gold but which began with the simple attraction of this precious metal. Gold's role as a store of value becomes particularly evident during times of economic crisis. When currencies falter, when stock markets crash, when inflation threatens to erode the value of savings, people turn to gold. This behavior, sometimes called flight to quality, reflects a deep-seated trust that gold will retain value even when other forms of wealth prove unstable. During the global financial crisis of 2008 and 2009, gold prices rose significantly as investors sought safe havens for their wealth. The same pattern has repeated during various economic disruptions throughout modern history. Central banks, which hold significant gold reserves precisely for this reason, understand that gold provides a form of insurance against economic catastrophe, a tangible asset that doesn't depend on any government solvency or any corporation's continued existence. The price of gold fluctuates based on supply and demand, on currency values, on economic conditions, and on investor sentiment, but the long-term trend has generally been upward. In 2020, during the uncertainty of the global pandemic, the price of gold exceeded $2,000 per troy ounce for the first time in history. This milestone reflected both the extraordinary circumstances of that year and the continuing role of gold as a refuge during times of fear and uncertainty. The price has continued to fluctuate since then, rising and falling with changing conditions, but gold remains one of the most closely watched commodity prices in the world, a barometer of economic anxiety and a measure of how much value humanity is willing to assign to this ancient metal. Gold continues to influence geopolitics and national economies in ways both obvious and subtle. Countries with significant gold reserves have economic options that others lack. Gold production can be a major industry and export commodity, shaping national development strategies. The gold trade creates diplomatic and commercial relationships. Disputes over gold deposits can influence territorial claims and international relations. Even in an age of digital currencies and complex financial instruments, gold retains a special status, a form of wealth that predates modern economics and that will likely persist long after current financial systems have evolved into something new. Governments still hold thousands of tons of gold in reserve, still track gold prices and gold flows, still treat gold as something more than just another commodity. When we step back and consider gold's full story, we see something remarkable, a connection between cosmic events and human civilization. The gold we value today was forged in the catastrophic deaths of ancient stars, scattered through space in supernova explosions billions of years ago, delivered to Earth by meteorites in the planet's youth. This cosmic origin links us to the larger universe in a tangible way. Every gold ring, every gold coin, every golden object is literally made of stardust, of matter that was created under conditions of almost unimaginable violence and heat. That this material should be so rare on Earth's surface, so beautiful, so chemically stable, and so useful seems almost providential. Gold connects the story of the cosmos to the story of human civilization in a way that few